Hi, this is Tom, and in this video we're going to look at the relationship between the exponential function and the logarithmic function. And in the last video we wrote exponential functions as logarithmic functions, and now we're going to write exponentials or logs as exponentials, and we're going to simplify logarithmic functions. So let's begin. Remember, we have this as our general relationship. We said that if y equals some number written in base b raised to the x, we use the if and only if statement to mean these are both true at the same time. Then what we would say is this is equivalent to taking the log in base b of the y term, and that gives us our exponent. So log base b of y equals x. And I'm going to write that out because saying that sometimes gets awkward. But this is spoken as log in base b of y is, or equals, is x. That's how you would say that. So let's try this. If I give you a problem like this, log in base 5, is that what I want to do? Now how about log base 2? Sorry, base 5 would be very difficult. Log base 2 of 32 equals 5. So if this logarithm is true, that means that there's also a corresponding exponential relationship as well. So whatever the log equals is always the exponent. So we know right off the bat we have something raised to the 5th power. And what's raised to the 5th power is always the base. So the base takes this position, and what the logarithm is takes the exponent position. So in other words, it's telling us that 2 raised to the 5th power is 32. And it is, as a matter of fact. Now, let's try another one. How about this? The log of 0.001 equals -3. So we're going to take the log and write it, the logarithmic function, and write it in its equivalent exponential function form. Now, this is a sneaky one. And it's not hard, it just gets, you have to get used to it, and that just comes with practice. But notice that there's no base written here. No base written. And we've talked about when things are implied, if the log has no base and it's log, then the base is 10. Base is 10. So what this means then is, remember, the -3 is going to be an exponent on something. So I have a -3. Oops. I have a -3 and a base. Well, we just said what the base is. It's implied to be 10. And we know that that has to give us what we're taking the log of, which is 0.001. And you can verify this if you take your calculator and take 10 and raise it to the -3 power. You will in fact get 0.001. As a matter of fact, let's just try that. That's a good calculator exercise. So here we go. Let's take 10. We're going to raise it to, now just to make sure that our notation is correct, I'm going to use parentheses in for what I want in the exponent. So -3, and then we'll go enter, equals. And there it is, 0.001. All right, let's go back now to Notability. Oh, and by the way, that's what all this is being done in, is Notability, and it's being done on an iPad Pro with the Apple Pencil. Let's try one more challenging one. How about if I give something like this? This is a difficult one. What about the natural log of pi? Oops, that's an x, not pi. The natural log of pi equals x. So that's its logarithmic function. what could we write? How would we write this as the exponent? Well, it follows the same pattern. Notice that the result, the x, or I'm sorry, what we're taking, the x is going to be our exponent in this case. So whatever the logarithmic function equals becomes the exponent. And notice that now it's not written as log, it's written as ln. Remember, ln stands for natural log. And the natural log always, we use that carefully, but we are using always, has base e. So there's my base. Oops, it's not supposed to be a 3. You shouldn't let me make those mistakes. All right, let's try this again. So my base we know is e, the exponent is x, and the result is we're somehow pi. What e to the what gives me pi? It's something a little more than 1, but I'm not quite sure what that is. All right, and so there we have e to the x is equal to pi. And so that is how you write logarithmic equations as exponential equations. We'll stop there, and in the next video, we'll actually evaluate some logarithms. Thanks for watching.